Hello, in our discussion today, let us discuss plucked string and struck string. We start with wave equation, the second order partial differential equation. Because the solution here we see is a function of both x and t. That is why we need solutions which can be factored into two parts. One part depends exclusively on the coordinate x, and another part which depends exclusively on the coordinate t. If I substitute the solution yxt equal to x of x and t of t in the partial differential equation, then the partial differential equation will get factored into two ordinary differential equations. These are two ordinary differential equations, and they are simple harmonic motions. This is an equation of simple harmonic motion. This is again an equation of simple harmonic motion. And we know the solutions of these differential equations. Cos mx and sin mx for this equation, whereas cos mct and sin mct for this equation. And we can multiply x of x with t of t to find the solution for the partial differential equation. So here we have multiplied these two solutions, x of x and t of t. And then we can rearrange these constants and put the boundary condition that the displacement will be 0 at x equal to 0. Displacement will be 0 at x equal to L. Then the solution can be written as yxt equal to sin n pi x by L cos n pi ct by L sin n pi ct by L. Here these constants a and b has got suffix n because this is the solution for the nth harmonic. And these constants, they also have dimensions because this is a number, this is a number, this is a number, and this has dimension of length. So an and bn should have the dimension of length. And once we have solutions for the nth harmonic, we can superpose all the harmonics and find a general solution yxt, that is sum over n, and this is ynxt sin n pi x by L an cos n pi ct by L plus bn sin n pi ct by L. This is the general solution for a string. Now we want to specialize this solution to the cases of plucked string and struck string. So here is the picture of plucked string. We pluck it at this point x equal to b here, and this is a picture of struck string. So the hammer strikes at the position x equal to b to x equal to b plus db because the hammer has a finite dimension. Now looking at these pictures, this picture and this picture, we can write down the initial conditions for plucked string and struck string. For plucked string, at t equal to 0, there is no velocity, but there is displacement. So from x equal to 0 to b, there is a displacement coming from this part of the picture, and from b to L, we should have a displacement r into L minus x by L, this part of the picture. For struck string, initially there is no displacement, but there is velocity between b and b plus db. So for b less than x less than b plus db, we should have the velocity as a positive constant. And all other values of x, we should have velocity equal to 0. So using these boundary conditions, we can find out the constants an and bn for plucked string and struck string. So for plucked string, let us start with velocity y dot xt and put the boundary condition of velocity here. At t equal to 0, this term goes away, but bn remains. And this has to be 0, so that gives bn equal to 0. So we substitute bn equal to 0, and then an remains. So how to find an? We have to use the orthogonality of the function sine m by x by l, sine n f by x by l. M and n is in general different. So using the orthogonality of sine n by x by l and sine m by x by l, we find out am. So am becomes 2 by l 0 to l yx0 sine m by x by l dx. Now we have to put yx0 here. That is the displacement at time t equal to 0. So if I put the displacement at time t equal to 0, my integration is broken into two parts, 0 to b and b to l. We can find out term 1 and term 2. We integrate term 1, we integrate term 2. I will also keep this PDF in the description box so you can check it for yourself. Term 1 and term 2. Then we add term 1 and term 2, and then we get am equal to 2r by m square pi square l square by b to l minus b sine m by b by l. We can see this, the dimension of am is here length square, here length square, so it cancels. And this is number, so this is just r, so that is length. So dimension of am is the dimension of length, so it is fine. So now the general solution in am, we have to substitute the value of am that we have just obtained here. We have to substitute it here, and then we get the general solution here, yxt. So here there are two things. One is the sine n by b by l. That means if n into b by l is an integer, then the amplitude is 0. That means b cannot be the place where there is a node. So we cannot pluck the string at one of its nodes. So that if we do that, then that harmonic will be absent. And also proportional to 1 by n square, which means that amplitude of the nth harmonic falls as 1 upon n square. Now let us go to the struck string. So in struck string, we can start with the general solution and put the boundary condition for displacement at t equal to 0. Then bn goes away, an remains, and this is equal to 0. That means an has to be 0. So if I put an equal to 0 here, then the solution becomes yxt equal to bn sine n by ct by l sine n by x by l. Now this bn has to be found. For that, again we use the orthogonality of sine n by x by l and sine m by x by l, and then solve for bn here. So bn, the solution of bn becomes 2 by m by c integral 0 to l, this is the velocity at t equal to 0, and sine m by x by l dx. Now this integral has to be done, and the velocity is non-zero only between b and b plus db, and that is a constant. So that constant comes out of here, out of this integration. So 2c0 by pi mc is b to b plus db sine m by x by l dx. And after we do the integration, put the limits, there is a cos factor, cos b plus db, and we use the trigonometric expansion cos A cos B minus sin A sin B, then this cos term will be cancelled, and what will remain is the sine term. So that means the B coefficient is now determined. Let us check the dimension of B. So this is a number, this is velocity, so velocity cancels. This is dV, dimension of length. So that means dimension of B is the dimension of length. That's fine, that is what we are looking for. So that we have to put in the general solution. Then the general solution becomes 2a by pi c inversely proportional to n, and then sine n pi b by L, and then sine n pi ct by L, sine n pi x by L. So the amplitude here is proportional to 1 by n. That means the nth harmonic, the amplitude will fall as 1 by n. And also there is this factor here, sine n pi b by L. So if this factor is 0, that note will be absent. So n into b by L cannot be integer. That means if I strike here in such a b that n into b by L is an integer, and that note will be absent from the sound. And what about this constant a? This constant is nothing but c0 dB. Here c0 dB, which has the dimension of length square by t. We put this length square by t, and this is velocity. This a by c has dimension of length, so that matches here. Yxt has dimension of length. So fine, we have got solutions for plucked string and struck string. For plucked string, we have got the solution here, 1 by n square, and for struck string, we have got the solution here, 1 by n. And the second point is that struck string has a richer sound, or it is more sonorous. The amplitude falls off as 1 by n for struck string, in comparison with the amplitude falls off as 1 by n square for plucked string. So I suppose this was interesting, and thank you for watching.